Figure 6.11, a scoping example. In this example, we're going to talk a little bit both about variable scope and also the duration of variables as well, or the lifetime of variables. Now, the scope of a variable is, of course, the part of the program in which it can be used. And in this example, we're going to be looking at a number of different variables named x, one at the global scope, a couple at local scopes in main, and also a couple at local scopes in other functions of our example. And basically we want to show you by executing this program and looking at the source code which variable is in scope at any given time. Now let me go ahead and run the program just to bring up the output so that we can switch back and forth between the output and the actual source code. So let's take a look at the source code here. You can see that we've got prototypes for three functions that will be used by the function main, one called useLocal, one called useStaticLocal, and one called useGlobal. The useLocal function is going to use a local variable declared within that function. The useStaticLocal function will use a local variable that is also declared static within that function, and we'll talk about what that means. And then useGlobal will use this global variable that's declared above main at line 11. Now, any variables that you declare in a source code file and not inside of any method or class are considered to be global variables, and that means basically the entire program has access to that variable and can use that variable. However, depending on what other variables are in scope, it's conceivable that the variable x at line 11 can be temporarily hidden. And in fact, one of the things we can do is run this program in the debugger as well, so that you can see as you move along what the value of x is at any given time. Unfortunately, it's a little hard when you're looking at the debugger to tell what variable it is. You can see the values changing, but it doesn't say anything in the debugger about whether it's a local or a global variable, etc. And for that reason, we're just going to bounce back and forth between our source code and the program's output here. So as we enter main in this example, the first thing we do is output the string global x in main is, and then we output the value of x. Now, in main, we have not yet declared any variables. The first thing we're doing is this output statement. So the only x that exists right now is the one at line 11, and when I finish executing line 15, I get the first line of the output window showing that the global x in main is the value 1. The next thing we do is declare a local variable called x in main, and that local variable is initialized with the value 5. And at line 19 we then output the value of x once again. But now, because we have a local variable that it has been defined before line 19 executes, the local variable temporarily hides the global variable while the local variable is in scope. So when I output at line 19 the value of x, we can see that the value is 5. Next, at lines 21 through 25, we create a separate scope within main by declaring a set of curly braces, an opening left curly brace at line 21 and a closing right curly brace at line 25. And even a block of code like this has its own scope. So when I declare another variable called x at line 22, it exists from line 22 until the end of the scope in which it is declared. So once we reach line 25, this version of x will no longer exist. Now, to prove to you that this x with the value 7 is currently in scope, we output local x in main's inner scope is, and we once again try to output x, and notice that the value 7 gets displayed. Then we hit the end of that scope. At that point, any variables declared within that block are gone. They are removed from memory. So when we go to line 27 and output the value of x again, we see that it's back to 5, the local variable declared higher up in main. And then we start working with our functions. And here we have two sets of calls to the three functions, useLocal, useStaticLocal, and useGlobal. So of course when we call useLocal, that's going to transfer control from line 29 to the useLocal function. Now in useLocal, it has its own scope defined by the body, and any variables that we declare within that scope are local to that function. And if they are the same name as any of the global variables in our program, which is of course once again the case here, they temporarily hide the global variable. So this version of x with the value 25 is temporarily hiding the global variable with the value 1. Then at line 45, I display the value of x in as we've entered use local and set its value. I increment the value and then I display it again. And let me just show you that part of the output here. You can see x is 25 when we enter use local, and it's 26 as we exit. Now once we reach that closing curly brace, any local variables in this function go away. So when I go back up to line 30, the local variable x in main is the one that's currently in scope. This one does not even exist anymore at line 43. Next we call use static local. So let's go down to the definition of that one. And here we have the static local integer called x, which is initialized to 50. Now static local variables are a little bit different from regular local variables in that the first time the function gets called, a static local variable is created and initialized. And that variable then exists from that point in the program until the program terminates. So its lifetime is from the moment its declaration is first encountered until the program terminates. But its scope is still inside the set of curly braces in which it's declared. So this version of x is only known inside the use static local function, but when I call this function again at a later time, it will still have its last value. So we set it to x the first time we encounter it. We set it to 50 the first time we encounter the declaration. We display that value. We increment it to 51, and then we display that value again. Now if I stop there and look at the next two lines of the output, we can see that the static x is 50 when we enter use static local, and it's 51 when we exit use static local. We'll come back to that concept again in a moment when we do our next call to that function. Next we call use global, and when that function gets called, you can see in its body that there are no declarations. There are no variables being declared. Therefore, when I use x in this function, it's going to be the global variable x. The compiler will always look for a declaration locally first. If it can't find it there, it's going to look for that variable in an outer scope, in this case the global scope, and use that variable instead if it exists. Otherwise, we'll get a compilation error. So here when we output x, we get the value 1. We then multiply it by 10 to get the value 10 and display that value. So if we stop there, you can see that the global x is 1 when we enter use global, and its value is 10 when we exit use global. All right, let's go back up to main, and now we're going to start the second set of calls to each of these functions. So once again we call use local. As we enter use local, the regular local variable x is recreated and reinitialized to 25. So we display 25, increment it, and display the value again, which is now 26, and that gives us this next set of two statements being output. And you can see that for the use local function, x was recreated and initialized to 25 again, just like up above, and its value is 26 as we leave, just like up above. Next, we call use static local again. Now this is the second call to use static local, so line 55 is not going to execute this time. That statement only executes the very first time this function gets called. So basically, use static local is going to use whatever the value of x was the last time this function terminated, which was 51. So we're going to display that value. Display that value here at lines 57 and 58. We're going to add 1 to it, and then we're going to display its value again. And if you look here, you can see that the local static x was 51 this time when we entered use static local. That was the value we left with on the last call. And we, of course, incremented it, so its value in memory is now 52. And if we were to ever call this function again, the new value upon entering use static local will be 52, and that will be maintained throughout the lifetime of this program. Then finally in main we call use global once again, and the global variable exists for the duration of the program from the moment the program is created until the program terminates. So when we go in at line 67 and display the value of x, it has whatever the last value of x was in memory, which was 10. I multiply it by 10 to make it 100, and I display that result. And you can see here that it was 10 when we entered this time, whereas it was 1 the first time. And it's 100 as we leave this time, whereas it was 10 the last time. So now the global variable x is 10, and is 100, excuse me. And if we were to call that useGlobal function again, it would start by displaying 100 and then multiply it by 10 to get 1,000. And then the very last statement in main is to just show you that at this point the only x available to us now in main is the one that was declared back at the beginning of main, which is the one with the value 5, and you can see that indeed the one with the value 5 is displayed. So what we were looking at here in this example is a combination of the scopes of variables, that is where they can be used in the program, and the life cycle or the duration of variables, which says how long they remain in memory during the program's execution. Any global variable is created when the program starts executing and exists for the entire duration of the program. Any local variable exists only for the duration of the block in which it is declared, and any local static variable exists from the moment its declaration is first encountered until the program terminates, but it is only in scope within the block of code in which it was declared, which means you can only use it within that block.